Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 22 video on the chapter of mensuration, where I will solve the problems of concept practice problems set number 3, where the problems are based on based on the area of square, rectangle, parallelogram, rhombus and triangle that I have discussed until the part 21 video on this chapter of mensuration. The PDF of the problem set of number 3 was given in the previous video, in the description of the previous video, that is part 21. Always try to solve the problems yourself first. Only if you are stuck and if you want to see my method of solving the problem, then please do watch the solution video. And so this video is part of the playlist CBSE Maths for class 7 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving the problems of concept practice problem set number 3 from the chapter of mensuration. Okay, so I have the problem set. There are 6 multiple choice questions in the set number 3. All these problems are based on the area of square, rhombus, parallelogram, rectangle and especially triangle. On the right hand side, I will solve the problem. Please note that a particular problem may be solved in various methods. I will solve the problems based on my understanding and knowledge, but if you solve them in a different way, that is perfectly fine. Always stick to the method and applying the concept that is that suits you best or is the most understandable or comfortable to you. Okay. Question number 1. The problem says that a wire of length L centimeter is in the shape of a square having area A1 centimeter square. It is ribboned to form an equilateral triangle having area A2 centimeter square. Then the value of A1 is to A2. So it is asking the ratio A1 is to A2. So when a wire of length L when a wire of given length is bent into a shape of a figure, then the length of the wire will be equal to the perimeter of the figure to which it is bent. So definitely the perimeter of the square and the perimeter of the equilateral triangle will be equal to the length of the wire, which is L. Okay. So for square we will have, since if we consider small a as the length of the side of a square, then we will have 4a is equal to L. So this implies L centimeter. So this implies a will be equal to L by 4 centimeter. So this implies A1 is given to be the area of the square. So we will have A1 is equal to A square, which is equal to L by 4 square, which is equal to L square by 16 centimeter square. So A1 is equal to L square by 16 centimeter square. Similarly, we have to find the area. We have to find A2 for the equilateral triangle. So for equilateral triangle, we know that the sides of an equilateral triangle are same. So we must have, if we consider A as the length of the side of an equilateral triangle, we will have 3a is equal to L. The perimeter of an equilateral triangle of where the length of each side is A is thrice A. So this must be equal to the length of the wire. So this implies A is equal to L by 3. So the side length of the length of each side of the equilateral triangle is L by 3. Now what will be the area of the equilateral triangle whose side length is A? We know the formula is since A2 is given to be the area of the equilateral triangle, A2 will be equal to square root of 3 divided by 4 and A square. We know that A for the equilateral triangle is L by 3. So we have L by 3 square. Okay. So this is equal to square root of 3 by 4 multiplied by L square by 9. Okay. This is equal to square root of 3 L square by 36. Okay, so now we have to find what is A1 is to A2. So this implies A1 by A2 will be equal to A1 is L square by 16 and A2 is square root of 3 divided by 36 and L square. L square will cancel out from numerator and the denominator, and if we simplify this, we will have 36 divided by 16 multiplied by root 3. If I simplify 36 and 16, it will be 9 and 4. So this is 9 by 4 square root of 3. A1 by A2 is 9 by 4 multiplied by square root of 3. So this implies A1 is to A2 will be equal to 9 is to 4 multiplied by square root of 3. So the correct choice is D. D is the correct choice. Okay, let's do question number 2. There is a figure for question number 2. ABCD is a rectangle where E and F are the midpoints of the sides AD and BC. So E is the midpoint of the side AD and F is the midpoint of the side BC. O is a point on the line segment EF. So if you join EF, we get a line segment EF, and O is a point on the line segment EF. Then the ratio of the areas of the shaded region and rectangle EABF is. Now O is any point. You can take O anywhere. Definitely O will not. I think the question should have clarified that O cannot be coincide with the points E and F. O is somewhere in between. Is somewhere on the line segment EF, but it is not. It will not coincide with E and F. So we have to find the ratio of the areas of the shaded region and the rectangle EABF. So we have to find the area of the shaded region. Now clearly we can see that. Okay, so let me quickly draw the figure. So this is the rectangle A, B, C, D. E is the midpoint of the side AD. F is the midpoint of the side BC. E and F is joined. So we have the line segment EF, and O is any point. O can be anywhere on the line segment EF. Let's say this is O. So now, okay, and also note that this triangle, this point, let's say I'm calling it G. G is also it is not given where the point G will be. G will be anywhere on the side DC. So we have formed the shaded region is formed of the triangle EGO and let's say the triangle this one. Let's say this is H. So the shaded region is formed by the triangles GEO and OHF. So I'm calling the regions, these two triangles, as let's say R and I'm calling this region as R1 and this region as R2. Basically R1 is the triangle EGO and R2 is the triangle OHF. So we have to find the area of the region R1 and R2. Okay. The interesting thing is that O, the point O, is anywhere on the line segment EF, and also the triangle EGO, the point G, I guess can be anywhere on the side DC, but it will not coincide with D and C. Okay, so how do we find, can we find, and it is asking to find the ratio of the shaded area of the shaded region and the area of the rectangle EABF. Now clearly, since E and F are the midpoints of the side AD and BC, we will have DE is equal to EA, and also CF is equal to FB. Okay, and also EF is equal to AB. So let us assume the breadth of the rectangle ABCD to be X and the length of the rectangle ABCD to be Y. So then what is EA? EA is equal to half of AD, which is equal to X by 2. Also, okay, we have this. So this implies what is the area of the rectangle EABF? This is equal to length multiplied by product of length and breadth, that is EA multiplied by AB. EA is X by 2 multiplied by AB, AB is Y. So this is XY by 2. X by Y2 is the area of the rectangle EABF. Now we have to find the area of the region R1 and R2. Okay. Now so I need to find the area of a triangle. I need since no dimensions were given. So in this problem no dimensions are given. We have to smartly assume the dimensions of the rectangles as whatever is necessary to find the area of the region R1 and R2. Now, so to find the area of a triangle, the easiest way is if we know the base and height. So let's say if I consider in the triangle GEO, EO is the base, and let's say this is perpendicular. Let's say this is GHI. Let's say GI is perpendicular to EO, and let's say from H I am drawing a perpendicular on EF. Let's say this be J. So I have GI is perpendicular to EF, and also HJ is perpendicular to EF. Okay. Now since okay. Okay. So GI is perpendicular to EF, which means that okay. So let me move this here. So we have this. We have drawn GI perpendicular to EF and HJ perpendicular to EF. So these two will imply that we must have GI parallel to DE, and we will also have HJ parallel to BC. So this will imply that GI will be equal to DE, which is equal to since E is the midpoint of AD, DE will be half of AD, which is equal to X by 2, and also HJ will be also equal to FB, and since F is the midpoint of BC, we must have FB is equal to X by 2. Okay. So now now let's see what is the area of R1. The region R1 is nothing but the triangle GEO. Area of the triangle GEO will be half the base, that is EO, multiplied by the height, that is GI. This is equal to EO we don't know. EO by 2 multiplied by gi is x by 2, x by 2. So this is equal to x multiplied by EO divided by 4. Okay. Now let's see what is area of the region R2, which is nothing but the area of the triangle OHF. OHF. This is equal to half the base we can consider as OF and the height as HJ. So OF multiplied by HJ. This is equal to OF, we don't know its length, but HJ we know is x by 2. So this is x multiplied by OF divided by 4. Okay. So what is now area? This implies area of shaded region. Area of shaded region. Area of shaded region becomes area of the region R1 plus area of the region R2, which is equal to R1, area of R1 was x multiplied by EO divided by 4, and area of the region R2 is x multiplied by OF divided by 4. If you simplify them, if you take x by 4 as common, I will get x by 4 multiplied by EO plus OF. Now what is EO plus OF? EO plus OF is nothing but AB, that is the length of the rectangle. This is equal to x by 4 multiplied by AB, and the length of the rectangle we have considered as y. So this is xy by 4. So now we can find the ratio. So this implies required ratio. The problem has asked the ratio of the area of the shaded region and the rectangle EABF. So the required ratio will be equal to area of the shaded region is xy by 4 and the area of the rectangle EA BF was xy by 2. xy by 2. So if we simplify this, so this will be xy by 4 multiplied by 2 by xy, and this is equal to half, which is equal to 1:2. So the required ratio is 1:2, and hence the correct choice is A. A is the correct choice. Now if I am doing any kind of calculation mistake and coming up with wrong answer and selecting the wrong choice, then please feel free to let me know in the comment section. I will appreciate that, because I am prone to make calculation mistakes. Okay, let's do question number 3. ABC triangle ABC is right angled at B, where AB is equal to 3x and BC is equal to 4x, and BE is perpendicular to AC. Okay, find the length of BE. Find the length of BE. Okay, so I'm not drawing the figure. So how do we find the length of BE? Now ABC is a right angle triangle. We know the length of the two arms or the legs. AB and BC are the two arms or the two legs, and their length are given. One is 3x and other one is 4x. So we can easily find out the length of AC by using Pythagoras theorem, since AC is the hypotenuse. Now if you know, if I know AC, then I can find the area of this triangle in two ways. One is by considering one as the half multiplied by product of the two legs. We know that in a right angle triangle, an area is equal to half multiplied by product of the two legs, that is product of the length of the two legs. Also the area will be equal to half multiplied by the hypotenuse multiplied by the perpendicular drawn from the opposite vertex on the hypotenuse. Okay, so first of all let's see what is AC. Applying Pythagoras theorem, we will have AC square is equal to AB square plus BC square. This is equal to 3x square plus 4x square. This is equal to 9x square plus 16x square, which is equal to 25x square. So this implies AC is equal to square root of 25x square, which is equal to 5x. Okay. So now area of triangle ABC, considering the two legs as the base and height, will be equal to half multiplied by AB multiplied by BC, which is equal to half multiplied by 3x multiplied by 4x, which is equal to 6x square. Also, now let find the length of BE. Okay, so let BE be equal to, let's say, T. Let the length of BE be equal to T. Okay. So also we can say the area of triangle ABC, considering the hypotenuse as the base and BE as the height. Since BE is perpendicular to the hypotenuse, we can consider hypotenuse as the base and BE as the height. This will be equal to half multiplied by BE multiplied by AC. This is equal to half multiplied by T multiplied by AC was 5x. This is equal to 5x T by 2. So now we need to find T. So this implies, so we can now 6x square is the area of the triangle ABC. Also 5xt by 2 is the area of the triangle ABC. So we must have 6x square is equal to 5xt by 2. From here we can cancel, we can divide both sides by x. Why? Because remember, in an equation we can always divide both we can always divide or multiply LHS and RHS by a non-zero number, and x cannot be a non-zero number. In the dimension no side, if x is 0, it means that the length of the side of a triangle is 0, which is never the case. In a triangle, the length of all the three sides are always greater than 0. So I can cancel out, or I can divide both the LHS and RHS by x, and I will get 6x is equal to 5t by 2. This implies x is equal to 5t by 2 multiplied by 1 by 6, which is equal to sorry, I have to find t, not x. Okay, so this means t is equal to 12x by 5. So the length of BE is 12x by 5, and hence the correct choice is B. B is the correct choice. Okay, let's see the next problem. Question number 4. In a triangle ABC, E and F are points on the sides AB and AC respectively, such that EF is parallel to BC, EF is parallel to BC, and AE is to B, AE is to AB is equal to 1 is to Q. If area of triangle AEF is A1 and area of triangle ABC is A2, then A1 is to A2 is. Okay, now this is a concept I have already discussed in my previous video, that let's say we have any triangle, let's consider the given triangle ABC. Now it is given that E and F are points on the sides AB and AC such that EF is parallel to BC. EF, so let's say this is E and EF is parallel to BC. Okay. Now if EF is parallel to BC, if you draw a line segment EF such that EF is parallel to BC, then you will always have AE by AB will be equal to AF by AC. This will also be equal to EF by BC. That means the point E divides the side AB proportionally in the same proportion as the point F is dividing the side AC, which also means that the triangle AEF and the triangle ABC are similar. Similar means they look the same. They are of same shape but of different size. So always remember this concept that whenever you have a triangle ABC and if you draw a line segment EF like this, where E and F are points on the sides AB and BC, and EF is parallel to the BC side BC, then this line segment EF will divide the sides AB and AC proportionally. That is, we will have AE by AB is equal to AF by AC, BC, which is equal to EF by BC. Now AE by AB is given to be 1 by Q. It is given in the problem. Okay. Fine. And it is given that area of triangle AEF is A1 and area of triangle ABC is given to be A2, and we have to find what is A1 is to A2. Okay. Now, how do we find A1 and A2? No dimensions is given, only that AE by AB is equal to 1 by Q. Also note that if you have this kind of scenario where, now please note this concept very carefully. ABC is a triangle. If E and F are points on the side AB and AC such that AE by AB is equal to AF by AC, then this will also mean that EF is parallel to BC. Conversely, if it is given that the line segment EF is parallel to BC, then also we can say that the point E will and F will divide AB and AC proportionally. That is, AE by AB will be equal to AF by AC. Now, let's say if I draw a perpendicular from the vertex A on the side BC. Let's say this be AG, and let's say this perpendicular is intersecting the line segment EF at H. Now, if you consider the triangle ABG, you will see that EH is parallel to BG. EH is parallel to BG. This means, so in triangle ABG, EH is parallel to BG. This will imply that AE by AB will be equal to AH by AG will be equal to EH by BG. EH by BG. Okay. So obviously, since AE by AB is given to be 1 by Q, we can say that this will be 1 by Q. Okay. Now, so AG has been drawn perpendicular to BC. So since EF is parallel to BC and AG is perpendicular to BC, this will also imply that AH will be perpendicular to EF. So we can say that AH is the height. We can consider AH to be the height of the triangle AEF and EF to be the base. So what will be now the area of triangle AEF? Area of triangle AEF will be equal to half into base into height. Base we can consider as EF and the height as AH. Okay. Now what is EF? Remember, we have AE by AB is equal to AF by AC is equal to EF by BC. So from here, sorry for my congested solution, but from here we can say that EF by BC is equal to 1 by Q. So I can say EF is equal to BC by Q. Okay, so this is equal to half multiplied by EF is BC by Q. BC by Q. And what is AH? AH by AG. AH by AG we know is equal to 1 by Q. So from this we can say that AH is equal to AG by Q. So now the area of triangle AEF becomes half into BC by Q multiplied by AH, and AH is nothing but AG by Q. Now this is equal to 1 by Q square multiplied by half multiplied by BC multiplied by AG. Now what is half into BC into AG? Half into BC into AG is nothing but the area of the triangle ABC. If we consider BC as the base, we know that AG is perpendicular to BC. So we can consider for the triangle ABC, BC as the base and AG as the corresponding height. So we can say that this is equal to 1 by Q square multiplied by area of triangle ABC. So this implies area of triangle AEF was given to be A1. So A1 is equal to 1 by Q square, and area of triangle ABC was given to be A2. So this implies A1 by A2 is equal to 1 by Q square. So this implies A1 is to A2 will be equal to 1 is to Q square. 1 is to Q square is the ratio of A1 is to A2. So the correct choice is C. C is the correct choice. Okay, let's do question number 5. In triangle PQR, PS is perpendicular to QR, UR is perpendicular to PQ, QT is perpendicular to PR. Okay, so in a triangle PQR, we are given all the three heights are drawn. That is, RU is the height corresponding to the base PQ, QT is the height corresponding to the base PR, and PS is the height corresponding to the base QR. And the length of PS, UR, and QT are given to be X, Y, Z. And PQ is given to be, the side PQ is given to be R, and QR is given to be P, and PR is given to be Q. Okay. So the length of the sides of the triangle are given, and also the length of the heights, the length of all the three heights are given, and we are asked to find P is to Q is to R. Okay. Now we have to find P is to Q is to R. Okay. That is the ratio of the ratio of the sides of the triangle. Okay. So we know that in a triangle we can find the area applying the formula of base into height. We can find the area in three ways, considering one of the three sides as the base and its and the perpendicular drawn from the opposite vertex on that side as the height. Okay, so I can say that area of triangle PQR, let's say this be A, is equal to half. If I consider QR as the base, I can say QR as the base, its corresponding height will be PS. This is equal to half multiplied by what is QR. QR is given as P, and what is RS? RS is given as RS is not given. No, sorry, PS. PS is given to be X. Okay. So this is PX by 2. PX by 2. Okay. Also, we can say that area A of the triangle area A, I am denoting capital A as the area of the triangle PQR. So I can say A is equal to, let's say, now consider PQ as the base and its corresponding height will be UR. So PQ multiplied by UR. this is equal to half what is PQ. PQ is R, and what is UR? UR is given to be Y. So this is RY by 2. Also area will be equal to, now if I consider PR as the base, the height will be QT. So this is equal to half what is PR? PR is Q, and QT is Z. So this is QZ by 2. Okay, so we have to find the ratio of X is to Y is, sorry, we have to find the ratio of P is to Q is to R. Okay, so let's find out PQR. So from area A is equal to Px by 2, I can say that P will be equal to twice A by X. Similarly, the area is A is equal to Ry by 2, I can say R will be equal to twice A by Y, and similarly I will get Q is equal to twice A by Z. So now I have to find P is to Q, P is to Q is to R. How do I find? Now this is, now here your concept of ratio and proportion will come. How do I find P is to Q is to R, where I know the values of P, Q and R. Now we see that all the P, Q and R all are in the rational form, and the denominators are different, X, Y, Z. So the concept is that I will try to make all the denominators of P, Q, R same. That is, the easiest way is I will try to make all the denominators X, Y, Z. Okay. So P is twice A by X. If I want to make, you know that in a rational number, I can, in a rational number, if I multiply both the numerator and the denominator by the same non-zero number, it remains the same. So I can, in the rational number 2A by X, I can multiply both the numerator and the denominator by YZ, and it will be same. So I have multiplied by YZ, and the denominator becomes XYZ. Similarly, Q is 2A by Z, 2A by Z. This will be equal to 2A multiplied by XY, and the denominator will be, I am multiplying both the numerator and the denominator by XY. So this becomes XYZ. Similarly, R is equal to, what is R? R is equal to 2A by Y. So I will multiply both the numerator and the denominator with XZ, so that the denominator becomes XYZ. XYZ. So now what will be the ratio? This implies P is to Q is to R, I can say will be equal to, what was P? P was 2A YZ by XYZ is to, what was Q? Q was 2A XY divided by XYZ is to, R was 2A XZ divided by XYZ. So P is to Q is to R is equal to, as you can see, in all the terms in this ratio, the denominator is same XYZ. So this ratio will be equal to, you can what was the concept of ratio and proportion? If I have something like this, so 1 by, if I have a ratio, let's say 2 by 3 is to 6 by 3 is to 7 by 3, will this be equal to 2 is to 6 is to 7? So in a ratio, can we multiply all the parts by some number? Will the ratio remain the same? I think so. I mean, I am having a little bit of confusion regarding the concept of ratio and proportion. If we have a ratio like this, x, y, and z, can we multiply all the parts of a ratio by some non-zero quantity, same quantity? I mean, is this equal to xk is to yk is to zk, where k is not equal to 0? Will this be same? I guess so. Now, if I am wrong here, please do let me know in the comment section. I will appreciate that. In my opinion, this ratio will now be equal to, in fact, you can see that in this ratio, 2a yz by xyz is to 2a xy by xyz is to 2a xz by xyz. In all the parts, there is one common thing, which is, so let me write it. So 2a, this is 2a x y z multiplied by yz is to, we have 2a. So 2a by xyz is common. We have xy and 2a xy z, we have xz. So now this this ratio, we see that in all the parts 2a by xyz is common, and we can I think we can ignore that. So this ratio will become equal to yz is to xy is to xz. So the correct choice should be D. Now please note that you must also see the other choices. Now choice A is x is to y is to z. That will not be the correct choice. Choice B will also be not equal to z is to y is to x. Now what about choice C? Choice C is 1 by x is to 1 by y is to 1 by z. Choice C is given as 1 by x is to 1 by y is to 1 by z. This should be equal to, if I multiply all the parts by xyz, this will be yz is to xz is to xy, which is definitely not equal to yz is to xy is to xz. So this is the ratio of this is the value of the ratio of P is to Q is to R. So the correct choice is D. D is the correct choice. Now, if I am wrong anywhere in applying the concept of ratio and proportion in this problem, please do let me know. I will appreciate that. Okay, let's do probably the last problem, question number 6. Okay, for the above triangles, find the ratio x square is to y square is to z square if they have equal areas. So there are three triangles, 1, 2, 3, and labeled by the, so figure 1 is equilateral triangle because all the sides are equal. Figure 2, we see it's a right angle triangle, hypotenuse is y, and also the legs are equal, all the arms are equal. And in the third figure, the triangle, it's an isosceles triangle, equal sides are of length z, and the height corresponding to the base is 3z by 5. Okay, it is given the areas of all these three triangles are equal. So what will be the ratio of x square is to y square is to z square? Okay, so let's see. Okay. Okay, so let's find out what will be the area of these three triangles. Area of I am considering, I'm naming the triangle as triangle 1, since the triangles are labeled with 1, 2, and 3. So area of the triangle 1 is nothing but this. It's an equilateral triangle having the length of each side as x. So the formula is square root of 3 by 4 xs square. Okay. So it is also given that the area of all these three triangles are equal. So let's say the area be equal to capital A. Okay. What is the area of the triangle 2? It's a okay. So it's a we have this. So it's a isosceles right angle triangle because the legs are of equal length and the hypotenuse is y. So if I consider the legs as, let's say, A, I will have, using Pythagoras theorem, y square is equal to a square plus a square, which is equal to twice a square. This implies this implies a square is equal to y square by 2. This implies A, that is the length of each arm or leg, will be equal to square root of y square by 2, which is equal to y by square root of 2. So area of the triangle, right angle isosceles triangle, will be a half into base into height. We can consider the two legs, the two arms, as the base and height. So it will be half multiplied by, since the arms or legs are of same length, A, which is y by 2, it will be y by 2 multiplied by y by not 2 square root of 2. So this is equal to y square by 4. This is also equal to A. Okay. And for the third triangle, the third triangle, you know that this is a isosceles triangle where the length of the equal sides is given as z, and also the height, considering and the height, this is perpendicular to the base. If we consider this as the base, let's say its length be b and this height be h. This height is given, to be 3z by 5. Now in an isosceles triangle ABC, let's say this triangle be ABC, and an isosceles triangle ABC where AB is equal to AC, and this AE is perpendicular to BC, then this AE will bisect the side BC. That is, we will have BE will be equal to EC. Okay, which will be equal to B by 2 if I consider the length of BC to be B. Now from Pythagoras theorem, I will have z square is equal to the height AE is given to be 3z by 5, this square plus BE square, which is B by 2 square. From here I can find B. So this implies okay, so this is equal to 9z square by 25 plus we have B square by 4. So this implies if I take z square term to the left hand side, I will have z square minus 9z square by 25 is equal to B square by 4. So this implies, if I simplify the left hand side, it will be 16 z square by 25 is equal to B square by 4. So this implies that B square is equal to 4 multiplied by 16 divided by 25 z square. So this implies what will be B? B will be equal to square root of 4 multiplied by 16 divided by 25 multiplied by z square. This will be equal to 2 multiplied by 4 divided by 5 z. This is equal to 8 by 5 z. So B is 8, the base BC is 8, 5 by Z. So therefore, area of the triangle 3 will be equal to half, the base is 8Z by 5, 8Z by 5, and the height was given to be 3Z by 5. So this is equal to, if you simplify this, it will be 12Z square by 25. So this is also equal to A. But the problem has asked to find the ratio of x square is to y square and z square. Now from this we will have x square is equal to 4a by square root of 3, and from this we will have y square is equal to 4 times a, and we have z square. From here we will have z square is equal to 25a by 12. So what will be now? X square is to y square is to z square should be equal to, x square was 4a by square root of 3, 4a by square root of 3 is to y square is what was y square? Y square is 4a. 4a is to z square is 25a by 12. How do I simplify this ratio? Definitely we can cancel out a from all the parts. Okay, so how do we now? So this is equal to a multiplied by 4 by root 3 is to a 4 is to a 25 by 12. Now I can cancel out a. Now in a ratio I can always multiply all the parts by some non-zero constant, or I can divide the parts by some non-zero constant. It remains the same. So in this I can divide all the parts by a, and it will be 4 by square root of 3 is to 4 is to 25 by 12. Now I have to simplify this ratio so that it matches with one of the given choices. So the concept is same. What will I do is I will try to make so 4. So this is as you can see we have rational terms, 4 by square root of 3 and 25 by 12, and 4 this 4 is nothing but 4 by 1. So I have to make the denominator same. So basically I have to take the LCM of all the denominators. What is the LCM of square root of 3 and 12? The easiest way is now the LCM of square root of 3 and 12 will not be equal to square root of 3 multiplied by 12, but to simplify this ratio we can multiply to get rid of the denominator. We can multiply all the parts by 12 into square root of 3. So this will be equal to I can multiply, if I multiply all the parts with 12 into square root of 3. Why 12 into square root of 3? Because the denominators are square root of 3, 1 and 12, and their product is 12 into square root of 3. So I can say this will be equal to this is to 12 into 3 multiplied by 4 is to 12 into 3 multiplied by 25 by 12. Now if I simplify each parts, it will be it will be 48 divided I think 48, okay, is to 48 is to square root of 3 is to 25 square root of 3. So I think it should match with B, but still the ratio we have got is not equal to the ratio as choice B. Let me divide. If I divide again with the ratio all the parts with square root of 3, possibly I am doing unnecessary calculation, but anyway, let's try to arrive to the solution. So I can always do this. So this now becomes 48 by square root of 3 is to 48 is to 25. It is coming close to the choice B. What is 48 by square root of 3? 48 by square root of 3, if I multiply both sides with square root of 3, it must be like this. And we have 48 is to 25. Further simplifying the first part, this becomes 48 square root of 3 divided by 3 is to 48 is to 25. So 3 divides 48 with 16. Okay, so 16 root 3 is to 48 is to 25. So now it is fine. So the correct choice is B. B is the correct choice. So with this, it comes to an end in solving the problems of chapter concept problems set number 3. These problems were primarily based on the concept of how to find the area of a triangle and its related concept. I hope solving these problems will give you a good evaluation of your understanding of the concepts of area of a triangle and also area of square, rectangle, rhombus, parallelogram, and all the concepts that I have discussed so far up to part 21. So if this video was beneficial, please like it, share it with your friends, and also please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will start discussing about the circumference and area of a circle. So please stay tuned. I will end the video here. Thanks for watching, and until the next video, take care and bye.